Hello, pre-calc students, and welcome to the start of Chapter 10. Chapter 10 is all about sequences and probability. So today we're going to start with Section 10.1, which is looking at sequences, and then in the second half of this section we'll look at summation notation. So we're going to start with some vocab here. So a sequence is an ordered blank. An ordered what? This is an example of a sequence. That would be an ordered list of numbers. So sequence is an ordered list of numbers, and we can call them, the first, second, third, fourth, so they're in order. Now, a term is a blank in a sequence. So a term is a number in a sequence. So you can, and the way we write that is we say, okay, if we're looking at the fifth term here is the number 7, and the notation we use for that is a with a subscript of 5. So that's the fifth term is what this means. So the fifth term is 7. And then a general term. So basically a general term is a formula that gives us the nth term in a sequence. So basically n could be any number. So it's a formula that could give us any number of the sequence. Basically, if you think about this sequence and I want to find out the 30th number, here's an equation that would give me the 30th number. Okay, so the formula will always have an a sub n here to find the nth term. You can plug an n into this formula. So write out the first 4 terms of each of these two sequences. So we're going to start with this one on the left here, the first 4 terms. To find the first term, that means I want to find a sub 1. So basically, I'm going to put a 1 in for n. So if I want to find a sub 1, the first term, I plug a 1 in for n, and I do 2 times 1 plus 5, which is 7. To find the second term, I plug a 2 in. A sub 2 will be 2 times 2 plus 5, and that will be 9. To find the third term, I plug in a 3. So 2 times 3 plus 5, which is 11, and then the fourth term is 2 times 4 plus 5, which is 13. So that's how you can find the first 4 terms. You just plug in the numbers 1, 2, 3, and 4, and here are the first 4 terms of the sequence defined by this formula. Second one here, you can see there's some more going on. First, to find the first term, I plug in a 1. I have to do -1 to the first power over 2 to the first plus 1. -1 to the first power is -1. 2 to the first plus 1 is 3. So the first term will be -1/3. The second term, to find the second term, I plug in a 2. -1 squared is +1. And then 2 squared plus 1 is 5. So the second term is 1/5. Find the third term, I plug in a 3. -1 cubed is -1. 2 cubed plus 1 will give me 9. So that's -1/9. And fourth term is -1 to the fourth, which is 1. And then 2 to the fourth plus 1 is 17. So there are my first 4 terms, -1/3, 1/5, -1/9, and 1/17. So that's kind of, in general, how sequences work when you've got an equation for a general term. Next, and this is one of my favorite parts of the year, you get to learn my favorite mathematical operation. Look, I know addition's pretty great, subtraction's wonderful, everyone loves multiplication and division. They're all just great, but if I had logarithms, sure, awesome. I love logarithms. However, there is one and only one operation that is my absolute 100% favorite, and that is called a factorial. Factorials. This symbol right here means 6 factorial, and the way you calculate 6 factorial is you do 6 times 5 times 4 times 3 times 2 times 1, and that is a total of 720. Another example here, 4 factorial is 4 times 3 times 2 times 1, which is 24. And yes, that's right, the symbol of a factorial is an exclamation mark. It's super exciting. So this doesn't mean just like 4, okay? It means 4 factorial, all right? Hashtag factorial. Okay, so now let's write the first 4 terms of this sequence. So you can see the formula for this sequence involves a factorial. So what you need to do is you need to plug in, to find the first term, you plug in a 1. So the numerator is 20, the denominator is 1 plus 1 factorial. So 1 plus 1 is 2, that means I need to do 2 factorial down here. 2 factorial is 2 times 1, which is just 2. So the first term will be 20 divided by 2, which is 10. To find the second term, I plug in a 2 down here. 2 plus 1 is 3, so my denominator is going to be 3 factorial, which means I do 3 times 2 times 1, which is 6. So my second term is 20 over 6, which would simplify to 10 thirds. Third term, plug in a 3. 3 plus 1 factorial would be 4 factorial. That means 4 times 3 times 2 times 1, which is 24. And 20 over 24 simplifies to 5/6. And then 4 factorial is, to find the fourth term, I plug in a 4. 4 plus 1 is 5, so my denominator is 5 factorial, which means I do 5 times 4 times 3 times 2 times 1, which is 120. And 20 over 120 is 1/6. Now there is a factorial button on your calculator. So if you want to find, let's say, 4 factorial, you can type 4, go to math, so you hit the math button, then you go over to this option right here that says probability, and you can see that option 4 right here is the factorial operation, and then your calculator can do 4 factorial. Ta-da! Alright, next. I'd like you to simplify the following. 13 factorial over 10 factorial. Now, if you go to your calculator, and 13 factorial is a really, really big number. Okay? Now you could use your calculator to then also do 10 factorial and divide them. So that's one way you could get the answer. But I'm going to do this a different way because the next problem will rely on something I'm about to do. So let's do this a different way to take a look at what happens here when we work with factorials sometimes. So basically what I'm going to do is I'm going to take this fraction, I'm going to write out the factorial, 13 factorial, as 13 times 12 times 11 times 10 times 9 times all the way down to 1. And then in the denominator I'm going to write out the 10 factorial, which is 10 times 9 times 8 times 7 and so on and so on and so on. And then you can notice something. I have a fraction. Bunch of numbers on top being multiplied together over bunch of numbers on the bottom being multiplied together, and a lot of these numbers are the same numbers. For example, on the top here I have a 10 here, and on the bottom I also have a 10. And then I have a 9 here, and then I have a 9 below it. So basically what this means is you can take any number you see on top and cancel it with the number you see on bottom. Because this is all multiplication on top, these are all factors. Since there's no addition or subtraction, you can cancel anything that is in common on top and bottom. So you go ahead and cancel anything that is in common, and you can see that, oh my gosh, look at all that stuff. So basically everything from 10 to 1 is in common. So the only stuff I'm left with is in the numerator. 13 times 12 times 11 is the result. So all I have to do is just multiply those three numbers together, which is 1,716. Okay. All right. Now, this kind of pattern here can be very helpful when you are dealing with things like this. So here I'm simplifying a fraction that is n factorial over n minus 2 factorial. So I'm going to apply the same kind of logic here. I'm going to write out the factorial. Now, with a variable, it's a little bit different, or it's a little bit harder, I guess, to write it out. But basically, when you do n factorial, that means you start with n, and you multiply it by, well, the way you do a factorial is the next number is 1 less than the number before it. So the next number is going to be 1 less than n, which is just n minus 1. And the next number is 1 less than that, which would be n minus 2. And the next number is 1 minus that, which would be n minus 3. And the next number is 1 less than that, which would be n minus 4, and so on and so on and so on, all the way until you get to what? When do you stop? Well, you can see whenever you do a factorial, you stop when you get to times 2 times 1. Now basically, the way I've written this out, the idea here is since n could be anything, there could be any number of numbers here. We don't know how many are in this ... It's however many you need until you get to times 2 times 1. And really, if n is a small number, we might not even need these ones because, you know, there's so few numbers on top. But this is the general way that you write this out. And then you have to do the same thing on the bottom. So I start with for this one I start with n minus 2, and then the next number I multiply by is 1 less than that, which would be n minus 3. And then the number I multiply by is 1 less than that, and so on and so on and so on, all the way down to times 2 times 1. So when you write it all out, you hopefully can see that there's now a lot of stuff on top and bottom that are the same. These are all things that are being multiplied together, so when I see an n minus 2 on top and bottom, I can cancel them. n minus 3 on top and bottom, cancel. n minus 4, cancel, and so on. 2 over 2 cancels, and 1 over 1. So you can see, just like in the previous problem, and hopefully because we wrote the previous problem out that way, this one makes a little more sense. You can see that all these factors cancel, leaving me with just n times n minus 1. And on the bottom, it's just, when I cancel everything, I'm just left with 1. So my result here is n times n minus 1, which you can distribute and get n squared minus n as your final simplified answer for this fraction. So that's it. That's it for today. Way to go. You just learned what a factorial is. Congratulations. You're amazing. Let me know if you have any questions.